All right, I want to walk you through some of the steps for this next homework. So we're looking at some tracking data for copperhead snakes. And I gave you the citation where I downloaded this from. This is some researchers at the University of Memphis. And if we take a look, um, they had a lot of snakes in their database. We're just going to look at one today. And so if we look at the CSV file, open it up in Excel, you can just see the different data. Basically, the most important data here are the date, when the snake was located, and also the coordinates of the site where the snake was located. And you can see some other information. Now, I've got a lot more information on this, but this is all we need for this assignment today. And so I'm going to go ahead and close this. And I don't need to save it. I didn't change it. And so we're going to start working with R and RStudio. And so you should have those installed. I had some other lectures that you should have watched to kind of give you some basics in R. So now let's go ahead and put this to work. So I've already written a script to handle all these data and to map them. And so I'm going to open that up in RStudio. And so let's just, again, take a look here at RStudio. You've got sort of four main panes in each corner. This upper left is where you're going to write your scripts or write your program. Down here in the lower left, this is the R console. And if you didn't use RStudio, if you just used R by itself, it would look like this. And you would have to type everything down here at this command prompt. And so RStudio makes things a lot easier because you can type things up here and it helps you with the syntax and it helps you to stay organized, and then you can save it, and so then you can just run from up here. Excuse me. Over here, there's several tabs that we'll use periodically to, basically anytime we're importing data or looking at data, that information will be up here. And then you've got several tabs down here to help run the program. So if we want to find files, look for our plots, install our packages, things like that. And there's a lot of other stuff that RStudio can do, but we're just working with the basics today. Okay, so the first thing we always want to do is set the working directory. And so this just tells R where to look for data files, where to save things. It's just like we did with the GIS software. It's so much easier to make one folder for an assignment and put everything in that folder. And so I've already created a folder for this homework, and I'm going to find it on this Files tab. And so this Files tab, if you look over here, you've got a button that if you click on it, allows you to browse and find the folder you're looking for. And so I can look here, mine's here, mine is here, and that's homework 16. And so when I do that, then if you look in this window, you can see all those files and folders that are in that folder. This is where, this is the folder I created, and I'm storing all my information in this folder. And I've got a lot more stuff in there than you do. That's just because I've been messing around. Don't worry about that. Okay, so the very first thing I want to do is tell R that this is my working folder. And so once I've chosen that folder, I'm going to come up here to More, Set as Working Directory. And if you look down here in the R command prompt, in the R console window, you can see that there was a command sent to R. Set Working Directory, and then it's got the name of the directory. And so sometimes when you do something in RStudio, well, every time you do something in RStudio, it actually is sending the correct command to R down here. And so you can always see what that command looks like. So if you don't remember how to do something, you can do it in RStudio, and then it'll show you what the command looks like down here. But the nice thing is you can, do something like set the working directory, which we just did, and now I've got the code for it. And so I can come down here and select that code and go Control C to copy it, and come up here to my script in this window and go Control V. And so now I don't have to go through all those steps. So I went through those steps and came over here and searched for the folder and then did more and set working directory. I don't have to do that ever again. I've got the code for it right here. So all I have to do is run this and it will set the working directory to this proper directory. And as always, try to put in as many comments as you can so you can follow your code. And so you do a hashtag, and then you can type anything after that hashtag. And so I just, set working directory, and that will help me just remember what each command does. Okay, and so now I want to hit save or Control S to save, because in this window I'm writing a script or an R program, and that's the whole point of using RStudio, is I can write these and save them, and then I can come back and rerun them in the future, and that can really speed things up and make life a lot easier for you. Okay, so I showed you the snake data in that simple CSV file that I opened in Excel. So we need to get those data here into R, and we can use this Import Dataset button. And we want to import from text base. Now you might want to try and do it from Excel, but don't. That's not an Excel file we were looking at. It's a CSV file. It's a text file we were looking at. And this from Excel sometimes causes trouble, at least it has for me. By using simple text files in that CSV format, it's foolproof, and that's the easiest way to go. So I'm just going to use from text base, and it goes to my homework folder because I set this as the working directory, and I've got that file here in this folder, and there's the CSV file that contains our data. So I'm going to hit open. Now it gives me this nice screen to help me check and make sure everything looks right. And so the first thing is the name. This is the name that I'm going to give to the data set. And so it kind of guesses at the name based on the file name, and it's pretty close, but I want to call this snake.4189.dat. And I like to name things with .dat so I know it's a data file, but you don't have to. The only real rule here is do not start a name with a number. You always have to start with a letter, but otherwise you can have mixes of numbers and letters. Usually you don't have to mess with anything here. It's smart enough to pick all this up, and the defaults are fine. And if you look down here in the bottom, this is what the data frame is going to look like. And that looks pretty good, so it looks like it's going to work. Now the one thing that every once in a while pops up is that it doesn't recognize that you have headings. And so if this is set to no, now you come down here and you can see that the data file is going to be weird, right? It's going to name, this first column V1 and the next one V2. And the first values are going to be the column headers, and then there's going to be the data, and that'll be a mess. That'll never work. And so if you ever import something and it looks like this, check this right here. And it should say you should have headings and you should have them chosen. But it did it all right this time, and 99% of the time it does it right. So if everything looks good, we're going to hit import. And so a couple things happened when we imported. One is that you see over here in this environment tab, we now have a data frame, and that's the name we gave it. And you can see that it's got 60 rows and 6 columns, 60 observations of 6 variables. It automatically opened it up over here, and it does this the first time. If you use this import dataset button, it will automatically open it up. And so take a quick look, and that looks good. We don't need that anymore. We'll close it. And also, again, down here, you can see that this is the command that RStudio sent to R. That's the command we need. So we're going to go ahead and copy this, Control C. And we're going to come up here and we're going to go Control V. And so now again, if we wanted to run this script later, we don't have to go through all those steps. We can just run this one line and it will automatically load in the data and give it that name. And so as always, we want to make a comment, load data into snake.4189.dat. You don't have to be as detailed, but I like being detailed with my comments. Now, one thing I'm going to show you is that you do see that this file name is really long and awkward. And since we set the working directory, we can take that whole part that's the working directory and just replace it with a period. And so now R is smart enough to know when it reads this line, it knows that it starts with the working directory and then goes from there to find the data. So that's pretty nice. Again, this symbol here, the less than with a minus sign, that's the same thing as an equals sign. And so we could replace that with an equals or just use this version, it doesn't matter. Okay. All right, since this is the first time we've run R, we need to install a few packages. And you remember packages are little add-on programs that allow us to do specific tasks. And so if we come down here to the Packages tab, these are all the packages that are installed. And a lot of them get installed when you install R. And then a lot of them you have to go and get later. And you just use them as you need them. This way you don't have to install every package that's ever been written ever. You only use install what you need. And so we've got several of these. And the first one we're going to start with is SF, which stands for Special Features, and it's a package that allows us to work with geospatial data. And so that probably is not installed on your computer. And so you'll need to go here to install, and you can accept the defaults, and in this middle box look for SF, and then you can see it. And make sure this install dependencies is checked, and then hit install. And R will automatically go and download everything and install everything, and you just need to sit back until it's done running. I've already installed this, so I don't need to do it again. And so if you scroll down here to the bottom of my list, you can see SF is right there. It's already been installed. All right. And so once it's installed, and sometimes you have to just be patient, it takes a while. So watch over here in the console and wait until it's completely done running. Now, you only have to do that once. You only have to install a package once per computer. Now, if you save your script and you go to a different computer, you're going to have to install the packages again. But even though it's installed, if you look here, the box is not checked. It's not activated. And so, again, this is so R doesn't have to load everything into memory every time. You only load in stuff that you need. And since we're going to use this one, I want to check this box. And when I do that, if you come over here to the console, you see you got some messages, and there's a warning message, but there's nothing to worry about. But that just, shows that it's activated SF, and now we can use SF. If we don't do this, and we try to use some of the commands that are in this package, they won't work. Now that's one way to activate a package. An easier way, again, is to do it programmatically. And so if you come over here, I've already written the code for it, and the code is library and then parentheses SF. And so if I run this line, that will automatically turn on the SF package. And if I haven't installed SF, I'll get a warning sign saying, hey, I don't, no such package. And so I know I have to install it. And so again, this makes your life a lot easier. And so let me just demonstrate. The way you run something in RStudio is you click so that your cursor is somewhere on that line, and you hold down Control and hit the Enter key. And when I do that, now that has activated the SF package. Okay? And so every time I want to use that package, I got to turn it on. Now I only have to turn it on once per session. Once it's on, it's on. And until I shut down RStudio, I'll still have access to that package. Now if you look, there's the next package we're going to use, which is called ggplot2. So again, if you've never used this, you need to install it. And come over here and go to Install and search for ggplot2, and you see it's right there, and then you would install it. Again, I have already installed it, and so if you look in my list, there's ggplot2. And again, instead of checking the box, I can just use library. And so I put my cursor on this line, I hold down Control and hit Enter. And if you look down at the console, you see that I got a message. And again, these warning messages are usually not at all critical, but that just lets you know that, okay, now ggplot's turned on. And now in the same way, there are 3 other packages we're going to need today: GGSpatial, Maps, and CalPlot. And we'll use these all a little bit later, but I like to just put them all at the top of my script and run them right off the bat so that they're all loaded into memory. And so you will probably have to go and install each of these the first time you use them, and then you have to make sure and turn them on. And once you do that, we're ready to start programming. Okay, so we've loaded in the data, we've loaded in all the packages we need. Now we can start plotting those snake locations. And so here's the first thing we're going to do, is we're going to set up the snake locations as a special feature data set. And this is just a special type of data set. It's nothing to worry about. But it's a data set that is good for mapping. And so we're going to use it. And so we installed that package called SF, which stands for special feature. And you see that we have a function here called st as SF. And so that's a function that will create an SF data set. And it's in that SF package. So this doesn't come with R. And so if we tried to run this and we didn't have the SF package or we didn't have it turned on, we get an error. Okay. So if you look at this code, you see that we're going to take the data set, and so here's that snake.4189.dat. That's the data from the Excel file that I sent you. We've loaded it in, and it's stored in this data file. And again, you can come over here and click on the name, and you see a tab that will open up, and you can see that this is what's stored in the data file with this name. This is what's in it. You got rows and columns just like a spreadsheet. You could also come down here and just type the name of the data frame, snake.4189.dat, and hit return. And you can see that it shows you the entire data frame. And so if you're ever trying to figure out what something is, you can just type its name down here and R will show you what it is. So we're going to take that data frame and convert it to an SF data type, just because we can plot it easier. Now this next argument is telling R where the coordinates are. So if we come back and we look at the data frame, you see we've got all these columns, right? And one column tells you the date, and one column tells you the species, and one column tells you which snake this is. But one column tells you the longitude, and one column tells you the latitude of each location. That's what we need if we're going to plot these data. R doesn't know that, so we have to tell R, hey, look, the coordinates are in lon and lat. And from there, it's easy to figure out. And I'm guessing that it's probably in the order x, y, because longitude would be x and latitude would be y typically. Now you see this, we've got it written with a C and a parentheses and a list. That's concatenate. That's just a programming thing, and you'll see that in R a lot. If you have a list of things that you want to put together, you just use a C and put them in parentheses, and that makes a list of them. No big deal. Now the last argument here, CRS, stands for Coordinate Reference System. This is what we've been talking about all semester. You got to know what coordinate system your data are using. And you'll recall that there's tons and tons of different coordinate systems. There's UTMs and state plane and Lambert conical conformal and GCS and all these different coordinate systems. And you'll also recall that nowadays each one has a unique EPSG code. And so we can just refer to those codes, and it's a lot easier to refer to the coordinate system. And so we're telling R, hey, the data that you're going to map are in the coordinate reference system number 4326. And this is the WGS 84 coordinate system. This is that coordinate system that's used by GPS units. It's the coordinate system that's used worldwide for latitude, longitude mapping. And so it makes sense, since our coordinates are in latitude, longitude, and they were taken with a GPS, then the data are in this coordinate reference system. But we have to define that. We have to tell R what system we're using. So we need all that information to make this special features data set. When we do that, we're going to give it a name, and the name is going to be Snake Loc. And so Snake Loc will be the same data, but in a different format that's easier to map. And so again, I just have to put my cursor somewhere on the line. Now I also want you to notice something. To make things neater, a lot of times after an argument, we'll hit return, and you see then there's a different argument on this line, and then a return, and then a different argument on this line. That helps to keep the program neat and easy to follow. And RStudio does a good job of helping to indent things to make everything nice and neat. So I can put my cursor here, or here, or here, and it's all the same line, because RStudio knows this is all one command. Now I want to show you something else before I run this. Let's say I typed this, and I got done, and I forgot that last parentheses. You see what RStudio does? Look, it's throwing up some warnings here, and it's throwing up a warning here. That's the advantage of using RStudio, is if you forget something, it warns you about it. It says, hey, there's something missing. And you can hover over the warning. You see unmatched opening bracket, or something like that. And you go, oh wait, yeah, I forgot my close parentheses. And when I close it, everything goes away. And so that's another advantage of using RStudio. Okay, so I can put my cursor anywhere, hold down Control and hit Enter. And if you look over here, you see now we have a new item, Snake Loc, which we just created. And if I click on it, you can see that it's a data frame that's exactly the same as my other data frame, but the geometry has been combined into a single column. And that helps R when it's trying to plot it. Cool. So the whole point of this exercise is to take those locations of a tagged copperhead snake and make a map out of them and plot them. Now later on we're going to work with those data, but right now we just want to plot them. And so we've loaded in the data, we've loaded in the packages, we've converted the data to an SF data type. So now we're ready to plot. And so you'll recall we loaded in a package called ggplot2, and that's a really good package for all kinds of figures and graphs and maps and anything. And so if you look at this first command, I've got ggplot, and I've got an open parentheses and a close. I don't have any arguments. And so when you see something like that, you're like, that's weird. Why do I have these parentheses? Well, you could put stuff in there, and sometimes you will put stuff in there. That's where your arguments go. And if you need to tell the command, some special details, they'll go in there. But in this instance, we don't have any extra details. But the ggplot function, when R sees this, it says, oh, okay, I'm going to plot something. And you'll also notice that I'm going to start with this plot, but then I'm going to build. I'm going to add other commands, and I'm going to keep adding these commands until I get the plot the way I want it. And so when I add a command, I put a plus sign at the end of the line. You can't put this plus sign at the start of the next line. You got to put it at the end of this line, then hit return. And now here's another command, geom_sf. Well, you remember our data is in an SF data set. And so this is saying, oh, we're going to plot one of these SF data sets. All right. Now, which SF data set are we going to plot? Well, that's an argument that goes here. So you see, we do have something inside these parentheses. Data equals snake loc. Snake loc, if you remember, you come back over here, we just made that. And if I click on it and you look at it again, it's a data frame with all this information about when we located our tagged copperhead, and it also has the coordinates. And so we have to tell R, hey, what do you want to plot? I want to plot this SF data frame. And so I put that inside these parentheses. And so, again, I'm telling R, hey, plot something, and then this is what you're going to plot. Now, again, I can put my cursor on either one of these lines because they all count as one big long statement. Hold down Control and hit Enter. And if you look, you see that that command got sent to R down here, but nothing else really happened. And so why didn't it plot anything? Why don't I have a map? Well, it's because I stored that map in this vector named P. And so when I said P equals, that means do all this stuff and then store it here. This is something you do in R a lot, because you can take big complicated things, like this is a semi-complicated statement here, and I can store it in P, and all I have to do is type that letter P, and it stands for all of this stuff, for all these results. But I just stored it in P. I haven't done anything yet. And so I come down here, and now I'm going to tell R, hey, plot P. And so again, you see here's plot is the function. This is, the command. And it's got parentheses for the arguments. Well, what do you want to plot? Well, P. Well, what's P? P is what I stored this whole map in. And so if I put my cursor on this line and go Control Enter, now if you look over here in the lower right, you see this Plots tab became active, and here's a map. And so we plotted all those snake locations. And it showed up here in this plot. And that's great. That's exactly what we wanted. All right, and so now the way I like to do these plots is to just keep adding commands and keep adding lines until I get the map or the plot to look how I want it to look. And so this is a good start. You can see that we have, the basic map of these snake locations, but it's not a very good looking map by any stretch. And so let's start playing with the format of this map. And so the first thing we want to do is we want to make the plot a little bigger. you see that the plot is just barely outside the most outermost points. I want to make this a little wider and a little taller, just because I want more space. And so if you come over here, look what I did. I've got the same statements as before, ggplot and geom_sf, and I'm storing them in the same letter P, but now I'm going to add a new line. So I've got my plus, and then I return down to this new line, and the new command is scale x continuous, and so that just tells me that I'm going to mess with the x-axis scale, and I'm going to change the limits, and so I'm going to change the minimum and maximum of that x-axis. And again, you can see this format where if I'm trying to make a list, I can use the C in parentheses, and you can have several things in a list if you want, but I just got these two things here. And if you look closely at the minimum of the x-axis, it's 89.989, which is west, so it's a negative 89.989. I want to go a little further west. And so I'm going to make my first, the minimum value on that axis is negative 89.9895, which is a little bit further west. And then if you look down here, the edge of the map here is 89.9875. And so I want to go a little further east here. And so I'm going to set my maximum value, negative 89.9870. And see, that's a little bit further east, isn't it? And so now when I, again, can set my cursor anywhere, hit Control Enter, and the plot didn't change because, again, I'm just storing that plot in this vector named P. But when I run plot P, so Control Enter, and you can see now my x-axis is a little bit wider. And so in the same way, I've got a new set of commands here. And again, if you look, I've got the same 3 commands that I've already used, but I'm going to add a 4th one. So I got my plus, return, and now I'm going to go scale y continuous. And with the same logic, I'm going to change the limits on the y-axis so that it goes a little bit further south and a little bit further north. And so I'm going to hold down Control, Enter, plot, and now you can see that my map is a little bit bigger. I have a little bit more space with which to work. Okay, so now I want to be able to identify this map and know what snake we're looking at, so I want to give it a simple title. So if you look over here, we've got the same 4 commands we've already used. We're going to add a new command called GGTitle. And within the argument for this function is just snake4189. And it's just going to make a title. So I'm going to Control Enter to load that into P, and then Control Enter to plot P. And now we've got the same map, but at the top it's labeled with what snake we're looking at. All right. So now I don't like this gray background with these grids on it. I want a nice, clean black and white background. And so if you come over here, you've got the same commands we've already done. And I'm going to add a new command called Theme Classic with no arguments. This is just going to add a theme to it, which is a way to kind of, control the formatting of a plot. When I plot P, now I've got the same map, but it's a lot cleaner looking, right? Okay. So the next thing I want to do is, this is a map. This is not really an XY graph. So I want to get rid of these axes. I don't really need those. I want just a plot of where the snake was found. So if you look, I got a next series of commands. Again, it's the same commands we've already done, but I'm going to add a new one called theme void. And that's just, again, themes are a way to control formatting. This is a quick way to just get rid of the axes. So I'm going to control enter, and then to plot it, control enter. And now I've got a map of all my snake locations. All right, well, now this title looks a little funny. I want this title centered, and I want it a little bit bigger. So if you come over here, I got a new set of commands. And the same ones as before, but now I'm adding a new command to the bottom of this string. Another theme, but this time, this theme is going to allow me to control the formatting of the plot title. Now, don't worry about trying to memorize how all these different formats are calculated. It'll drive you crazy. And there's always more than one way to do the same thing in R. I'm just showing you my way, and my way works. So just take a look at this, and you can see that you're going to look at the plot title, and the text, you're going to horizontally justify it 0.5. That means you're going to justify it 50% of the way from left to right, or in other words, you're going to justify it in the center. Size equals 20, that just means font size 20. You're going to make a bigger font. So I'm going to control enter, and then control enter on the next line. And now you see that we've got a little bit larger title. No big deal. Okay. Since this is a map, it needs a scale bar and a north arrow. And so if you look at this new code, again, it's the same code as before, but we've added a new command at the bottom, annotation, scale. And for arguments, so this annotation scale is going to add a scale to the map. It's going to put it in the BL, or the bottom left, and the width hint is just basically, I think it's just how wide, how big it's going to be. I'm not real sure. I don't remember what this is, but it works, so just go with it. Control enter, and then on plot P. Oh, now there's a good example. There's a good example. So I tried to run this annotation scale. I tried to run all of these. And if you look down here at the bottom, I got an error. Could not find the function annotation scale. Well, why not? Because this is in one of those packages. And that tells me that I have not loaded in all my packages. And so I've installed the package, but if I don't turn it on, then R doesn't know how to use it. And so when you try to use something like annotation scale, which is in one of those packages, you get an error. So if you get this error, you probably did not install the package or turn it on. So let's go back up to my packages. And that annotation scale is in GG Spatial, and I've never turned it on. So I'm going to click on that line, control enter. And then while I'm here, I'm going to control enter on the library maps and control enter on library CalPlot. And so I probably forgot to do that earlier. And so now, for sure, those packages are installed and activated. So now when I come back to this series of commands, I'm going to hit control enter, and then to plot, control enter, excuse me. And it worked. And that's what happened. So I had not turned on that package, and so R threw me an error. But in the meantime, if you'll notice, I've got a nice scale bar now. I also need a north arrow. So if we come over here, again, same, all these commands, you see how we're building. You see, this is how I like to do these maps, one step at a time. Do one thing at a time until you keep making the map a little bit more like you want and a little bit more like you want. And so now we're going to add annotation north arrow. And so this is going to add a north arrow. Again, in the bottom left, it's going to do the true north versus instead of the magnetic north, which makes you usually want to use the true north. And these arguments are just kind of helping decide where to place it. You can play with those a little bit and see how they affect things. This is the style of arrow we're going to have. So I'm going to Control Enter. Then on the plot P, Control Enter. And now I've got a north arrow as well. Awesome. So now we've got the map that we were looking for. All right, at this point, if we have a map, we want to export it so we can put it into our document or a poster or whatever. So the easiest way to do that is to go to Export, copy to clipboard, and then down here at the bottom of this window that pops up, you've got Copy Plot. So now it's on the clipboard, and so if we launch Word or something, and I go Control, hold down Control and hit V for paste, there I pasted it. And so that's an easy way to get your map from RStudio and to paste it wherever you need to paste it. All right, one of the last things we want to do is to add an inset map. And so sometimes we like to add a little small map up in the corner that gives us an idea of the general location of the big map that we're looking at. And so these snakes were tagged in a park in Memphis. And so we'd like a small map that kind of shows in generally, you know, where Memphis is, or where in Tennessee, or where in the United States this was, depending upon, you know, the audience. I would like to have a little inset that shows an outline of the state of Tennessee and shows where the snakes were in Tennessee. And so we're going to do this in R, of course. And so if you come over here, you see I've got a command called statedf equals map data state. And so again, one of those packages that we loaded in contains a lot of maps that we can use. And so by using the command map data, we can decide what maps we're going to use. In this instance, we're going to use the state maps. So we're going to pull out the state maps and we're going to store them in a data frame named statedf. So again, put my cursor on here, hold down Control and hit Enter. And nothing really happened, but if you look over here, you've got a new data frame named statedf. If I click on it, you can see that I've got some simple data here. And basically what this file does is it's got latitude and longitude of points that draw an outline of the state. And so you've got lots of data here, which you see for Alabama, you've got a bunch of points, and all those points, if you did connect the dot with those points, it would draw a picture of Alabama. And hey, look, here's Kentucky. And if you used all these points and did connect the dots with them, it would be Kentucky. So it's got all 50 states in there. But we only want Tennessee. So I come down here, and I'm going to subset that data frame. So subset is exactly what it sounds like. It's to make a subset, to pull some data out of a data frame. And so I'm going to pull the data out of this data frame I just built. We just built this state.df data frame. It's got all the states. We're going to subset it. What do we want to pull out of there? We want to pull out the ones that are labeled region equals Tennessee. And so if you come back here and look at that data frame, you see region is the column that gives you the name of the state. And so I'm saying all the data in this data frame that are labeled as Tennessee, pull those out and store them in a new data frame called tn.df. Now, one thing you got to notice is here you've got a double equals, two equal signs. What? What is that? Okay, it's the difference between asking and telling. If you're ever telling R to do something, it's a single equal sign. So if you look to the left here, I'm saying, I'm telling R, hey, this is a new data frame, and you put this stuff into it. I'm telling it, put this in the data frame. Set these two equal. I'm giving it a command. But if I'm asking, it's two equal signs. I'm asking, hey, are these two things equal? So here I'm saying, hey, is region equal to Tennessee? If it is, pull it out. And so that's the difference between a single equal sign and a double equal sign. And so don't let that mess you up. So at any rate, now I've got my cursor on there, Control Enter to run that command. If I come over here, now I've got a new data frame named Tennessee.df. And if I look at it, you see it's the same kind of data as before, but it's only Tennessee. It's only where a region equal to Tennessee. So now if I play connect the dots with these coordinates, I can draw an outline of Tennessee. So let's do that. So if you look, I'm back to using ggplot again. And this time, instead of naming my plot P, I'm going to name it Inset, because this is going to be my Inset map. Now, last time I went step by step and I showed you what each step did, and we built it and ran, added a step and ran it, added a step and ran it. But you don't have to do that. You could put all the steps in and run them all at once, but you're going to make a mistake. So I have already built this one piece by piece. And we don't necessarily need to go through every command here. You can look at these and kind of recognize some of them. You can probably figure out what some of them do. But here, again, you see the same thing as before. I've got ggplot and then command after command to build this map exactly how I want it. And I'm going to store it in this vector named Inset. So I'm going to put my cursor somewhere on there, go Control, Enter, and then I'm going to plot Inset. And so now I'm going to take a look at that map. So again, put my cursor on there, Control, Enter. And look at that. There's a nice outline of Tennessee. And I've also put a dot where Memphis is. Now if you come back up here and look at the commands, you can see where that dot came from. Here's geometry point, so draw a point. And I gave it specific coordinates for that point, which is right there in the park. At any rate, so now I have this map of Tennessee with Memphis located, stored in a vector named Inset. And if you come up here, whenever you're doing plots in RStudio, it saves all of them. So I can do this back button, and there's my map. And you remember that map is stored in the vector named P. And in fact, I can scroll back and I can look at all my earlier maps. But only the last one is stored in P, and then this Tennessee map is stored in Inset. So that's the beauty of like storing these big complicated things in a simple vector with a simple name. I can just refer to that and get the whole thing. And so, if you come and look at these last commands here, you see that I'm going to do a new command called GGDraw. And that function is in that cowplot package. And so you remember one of the packages we loaded way back when was called cowplot. And it's got a function called GGDraw. And then we're going to draw plot P. So it, just like we did before, it's going to plot that map that is stored in P. It's going to plot my main map, which is what I want. But then it's also going to plot the map that's stored in the vector named Inset. And you remember that map is the Tennessee map. However, we're going to control how big that map is and where it's mapped. So it's going to go 65% from left to right and 65% from bottom to top. The width is going to be 30% of its original size. The height's going to be 30% of its original size. So I'm going to take this map of Tennessee, I'm going to shrink it, stick it off to the side of this map. And the way I do that is with these commands here. So I'm just going to put my cursor on there, go Control, Enter. And if you look, there's your inset map of Tennessee showing where we're located. Here's all the places where we saw that snake. Scale bar, so you have a feel for how much the snake moves. North arrow, and what snake it is. Everything we need for this map. And so again, I can go Export, copy to clipboard, then copy the plot, come over here to Word, give myself, let's just get rid of that old one, Control V to paste, and there you go. And so that's simple plotting in R, and then we're going to build upon this and start doing some analysis in the next homework.